For this spec, we'd like to use the midpoint approximation method to approximate the area underneath a function on some interval. In this example, we have the function 1 over x in the interval from 2 to 10. In this case, if we use M4 to approximate, well, M4 is delta x times f of x1 bar plus f of x2 bar plus f of x3 bar and plus f of x4 bar. And you remember that xi bar is simply the midpoint between xi minus 1 and xi. So when we generate the intervals, we're going to take the midpoints instead of the left or the right. All right, so if we start with delta x is still the same. It's still b minus a over n. So we get 10 minus 2 over 4, and that's going to be 2. Xi is again still a plus I delta x. So x naught is going to be just 2. x1 is 2 plus 2, so that's 4. x2, if we add another 2 to that, we get 6. Another 2 to that, we get 8. And another 2 to that, then we get 10. So to compute the midpoints of each one of these intervals, we need to do xi bar is xi minus 1 plus xi divided by 2. So x1 bar is the midpoint between x0 and x1. Well, the midpoint between 2 and 4 is 3. And the midpoint between 4 and 6 is 5. The midpoint between 6 and 8 is 7. And the midpoint between 8 and 10 is 9. Okay, so now we have everything we need, so we can simply write out what M4 is. So delta x is 2. And then we have the xi bar values 3, 5, 7, and 9. And we're going to evaluate the function at each of those values. So we get 1 over 3 plus 1 over 5 plus 1 over 7 plus 1 over 9. And that would be the approximation underneath the function 1 over x from 2 to 10.